Okay, uh, we are gonna talk about. Uh, we're gonna to give you some background of what we learned in uh, college algebra. That we have linear equation. We are gonna find the equation. We find the slope. You know, uh, you learned this already in college algebra. See here, there is a temperature here, and this is hour. At 4 o'clock in the morning, temperature is 50. At 8 o'clock is still 50. In 4 hours, it has not been changed. Okay, and then at 2 p.m. it's going to get to up to 80 degree Fahrenheit. This is Fahrenheit. You have to write this is the time. Always write what those axes mean. The x-axis is time in term of hour. We could have time in term of minutes or second, and here temperature in term of Fahrenheit. We have Celsius, the degree in Celsius, the degree in Fahrenheit. So at 14 2 p.m. is going to be 80 degree, and then at 18, which is 6 o'clock in the afternoon, is going to get 40. It's going to get cold. Just an example. This is just an example. Probably, just an example. Okay. Now, you want to find out the equation of this. What is the equation of this? See, what the slope is y2 minus y1, x2 minus x1. Means there are 2 points. Like this is if point 1 and this is point 2. So what is at point 2 we have x2, y2, x is 8, y is 50. At point 1, at 4 o'clock, still we have 50 degree in Fahrenheit. So we find this m. What is going to be m of this? y2 minus y1. This is y2 is 50, but minus y1 is the same 50. And the same x2 is 8 minus 4. It's going to be 0. It's going to be 0. The slope is 0. See, just a straight line. And if you want the equation of this, you write the equation of this like this: y minus y1 is equal mx minus x1. Okay, that's the total. That's the general formula. So we have y minus y1. Y1 is here. This is at point 1 y. This is axis y. This is axis x. Okay. Axis x in hour, axis y in temperature in Fahrenheit. So y1 is gonna be 50 is equal to 0 times x minus, what is that? This is a point. See, these are the points. This point could be this one at 4 hour, at 4 o'clock in the morning, temperature is 50, or 8 o'clock. Any of these 2 points, we can use that. We use this point here, x minus 4. So this is 0, y is equal 50. So actually the equation of this is y is equal to 50 from here to here. Okay? And then, so we find out that this equation of this line is 50. See, okay, that's the germ. Okay, now we are gonna talk about this, find the equation of this line, the slope. This is the slope was 0. Here the slope is positive because it's from here to there, it's going upward, and this is going downward. This is going negative and this is positive. So let's find out what. First we have 2 points. See, either you have to have 2 points or 1 point with the slope. We see the formula here. If you have the slope and 1 point, the point has x and y, and you put it in there, you find the equation of that line. So now let's find this. The equation of this line from here, from 8 o'clock in the morning to 14 or 2 p.m. There. So we will say y2 minus y1. This is now, okay, this is point. From point 1 is going to point 2. This is going to be y2, x2. What is x2? y2, x2. First of all, we use the y80 and then 14. This is the coordinates of point 2. At coordinates of point 1, it write it here, it's x is 8. See, no, first x, it is first x. X is 14 and y is 80. This is x, always x and y. The first one is x. Okay, x is 14, at point 2 x is 14 and y is 80. At the point 1, x is 8 and y is 50. Okay, 8x and 50 is the coordinates of the point 1. Now we are going to use that. y2 m is equal y2 minus y1 x2 minus x1. This is very famous formula that you got to use. So let's find the equation. Now it says y2. y2 is what? This is x and y. So y2 is going to be 80. 80. We write 80 here. Minus y1. y1, the point 1, y is 50. So we write 50 here. And then x2. x2 is 14. This is point 2. So x2 and y2. So that's going to be x2, y2. And this is x1, y1. Okay? x1, y1. So you say x2 is going to be 14, x1 is going to be 8. So 80 minus 50 is going to be 30, 14 minus 8 is going to be 6, so it's going to be 5. So the slope is 5. Okay, the slope is 5. What is the the temperature per hour? This is temperature Fahrenheit and this is hour. So Fahrenheit per hour is going to be the unit of this number 5. So we write here 5 and we use the equation, the general formula, y minus, we use a 1 point, okay? Now let me explain to you that if we use this what point? Y 50, and we use this the point 1 for this. We could use y for point 2, y minus 80 is equal 5 times x minus 14. So y is equal to 5x minus 90 plus 80. Y is equal to 5x minus we use 5 here. We are going to get the same answer. Oh, okay. We are going to get the same answer. This is going to be 5 times x is going to be 5 minus 5, 1, 5 is going to be 70. 70, and then y is equal 8 is going to up there, it's going to be plus, 8 is going to this side, it's going to change its sign, so 5x plus 10. So no matter what point we use, we are going to get the same answer. See, we use this point here, 8 as x1 and y as 50 as y1, and then we 5x minus 5 times 8 minus 40, and 5 is going to come to this side, it's going to be plus, and then 5x plus 10. That's going to be equation of this part from here to here. Now, for example, if you want, okay, if you want somewhere like this, we say, okay, we have 12, if you have the equation of the line, in the middle you can find what is, if the hour is 12, x is 12, y is going to be 5 times 12 plus 10, then it's going to be 60 plus 10, it's going to be 70. So if it's right there, this is going to be here. Okay, this is going to be 70. Probably if you get 10 here, it's going to be 60. See, this is linear equation. So if you find a point in the middle somewhere, you can give x, whatever x is it. If you put 10, 60 plus 10 is going to be 50 plus 10 is going to be 60. So if it's 10 here, this is going to be 60. Okay? This is 60. So these are the things you can find it from this graph. Now we get to the other part. Okay? We get to the other part. See here, the same things. We use, this is point 1. From point 1 is going to point 2. Okay? Point 2, y2, this is 40. If you have to know this, you know, it tells you this is 40 and 18. This is the 18, 40, and this is 1480. Okay? So we say point to y2 is 40 minus y1 is 80, and 18. x2 minus x1. 18 minus 14 is going to be minus 40 divided by 4 is going to be minus 10. The slope is negative. Minus 10 Fahrenheit per is going to be every hour is going to be 10 reduced by 10. Okay, this is like if you want to at point 15 minus 10 it's going to be 70, and then it, you know, that's the way. And then now you want to find the equation of this. You have the slope minus 10. Okay, we choose one of these points, either this one or this one. Now we choose, for example, this point, 14 and 80. 14x and 80 is y. So y minus 40 is y, and then minus 10 the slope times x minus 18. 18 is this. We use 1 point, and then we have a slope, then we can write the equation. Now minus 10x plus 180, and then 40 is going to come to the other side, is going to be plus 40 is going to be 220. Okay, so if you want something here at 16, it's going to be somewhere, probably it's going to be the 60 in the middle here. So what's going to be, see, y is equal minus 10 times 16 plus 220. Minus 160, okay, minus 160 plus 220 is going to be plus 60. So this is going to be here. This is going to be 60. So the coordinates of this is going to be 16 and 60. So that's the for linear equation. The slope is negative. You know, we try to show you all in one graph. The negative, positive. Okay. Now there is another. If somebody, for example, if somebody, this is equation. If somebody here is 6.10 in terms of feet, you can sign if you feet or meter, and a triangle stone. The stone is going to go this way, and then it's going to come this way. So what we are going to do, what the problem wants, the first things that the x, you know, this is x, this is y. This is the elevation, and this is the horizontal distance. Okay, now we are gonna find out first of all that at x, we write the equation. Okay, h of t in terms of time, in terms of x, this is x. The equation is like this one, minus 0.15 x2 plus 0.98 x plus 6.1. See, here you can find at any x is like 4, 5 feet, 6, 7 in terms of feet. If you want to talk about feet or about meter, whatever, talks about feet. In 10 feet from there, what is going to be the hy? This is h of x. H of x is a function of x. This is function of x. is gonna, first of all, first find the top point here. How do we find it? You know, we learned that in quadratic equation, this is downward. The curve is downward, and it's the maximum point. See, we learned that x is equal minus b over 2i. What is b? B is 0.98 minus, and then r is this one, minus 0.15 times 2, there are 2. Okay, 2r, 2 times this one. If you find this one, it's going to be 22.1. 22.1. If you put in the calculator, what is that? Yeah, 32, I'm sorry. 0.98. 0.98 divided by 0.015 times 2, the close parentheses, is 32.67. We rounded to 2. To 2 decimal places. Okay? 32. And this has a negative, this is a negative, and the negative cancels out, and this is 1. So it's going to be 32.67. So it means here is 32.67. And then if you want to find what is the h of x, the y, the height, see, if you throw a stone, it's get to a maximum point, the velocity is going to be 0, and then it's going to go down, and where it I'll show you where it hits this axis, it hits the ground. So what you do, you put this one minus 0.015 times x is 32.67 to the power of 2 plus 0.98 times x, 32.67 plus 6.1. Okay, if you compute this one, it's going to be 22.11. Okay, you raise this one to the power of 2 and multiply by this, and this is negative. And then this is negative, and then this is going to be positive. It's let's see, 32.67 to the power of 2 times 0.015 is going to be 16. This is going to be minus 16.01, and this is going to be 0.98 times 32.67 is going to be plus 32.02, we rounded, and plus 6.1. And if you add this together, plus 6.1 minus 16.01, yeah, 22.11. we round it. It's 22.107, but we round it to. So this is going to be feet. This is going to be feet. There, you have to write the unit. So this is going to be here 22.11 feet. This is in terms of feet. You have to write the unit. This is in terms of feet. This is the x horizontal, and this is the height. This is the horizontal distance, that is the vertical distance. It goes up to this point, the x. You know, every point has two coordinates, x and y. This is x in terms of feet, and this is y in terms of y. And when there is something we are two-dimensional, you know, it's something in the air, x and y. This has x coordinate and this is y coordinate. So this is x and y. Well, if this x is 2 and y is 3, you write it coordinate x2, and then, you know, we already talked about this. So one of the things you find out, that is the height, and then if you want how much is going to be what is going to be this point? It's going to be so y is 0. It means this one is 0. So this is 0, h of 60 is 0 minus 0.015 x2 minus 0.98 x plus 6.1. And what I do, I put this in the calculator. You know, you put this in the calculator, and you know, I don't know if you can see it or not. Okay, you use minus here. The first one minus is this one, minus 0.015, and this. And then if you do that, and then you calculate second value for 0, where it's going to be 71. Okay, let me see. $71.06. This is going to be 71.06. See, if you set it to 0, you know, you can find this equation. You know, you put it, you can use this general formula, plus minus b plus minus b plus minus b to minus 4a3 ac to r. You know, this formula, we can use this one to find out what. Okay, now you see that this is where it hits the ground. If you find something like this here, you just put in the formula here, like for example, it's 28. If you put 28 instead of x, then it gives you this one here. Okay? But actually, you know, this equation, the quadratic, it's going to be like this. Okay, thank you very much for watching, and we